So in morning session we studied one-dimensional array and pointers. So now we are going to discuss about two-dimensional arrays and pointers. A two-dimensional array in C is treated as a one-dimensional array whose elements are one-dimensional arrays or the rows. So we all know what is an one-dimensional array. So here two-dimensional array means one-dimensional array whose elements are one-dimensional array. So just like inside every cell we have some other array. Just think like this. Okay. So here you have to look like in this diagram, you just think like this array contains 4 elements, index position 0 to 3. And index position 0 contains another array which contains 3 elements. Similarly, in the first row contain another 3 elements. So it can be considered as an one-dimensional array whose elements are also one-dimensional array or the rows. Each elements of array are stored in successive increased location of memory. So it will be clear in the next slide. So here I have A00, A01, 02, 10, 11, 12 up to 32. So in memory, it will be in continuous locations. It will be in continuous location or in contiguous location or in successive location in the incrementing order. So every elements, first row, then followed by second row, followed by third row, followed by fourth row. Everything will be in continuous order. Figure 7.9 is the logical layout of a two-dimensional array in memory, but it does not give a good picture of what happening internally. This is actually 7.9. The internal pseudo memory map works just to display what the two-dimensional array looks like within the system and can be used to illustrate how it is actually implemented. So this is the internal representation. So figure 7.10 is the graphical representation of a two-dimensional array. So this diagram is actually 7.10. This may not be the accurate picture of what is actually stored in memory, but it is accurate in terms of concepts of a two-dimensional array. So here, when we studied one-dimensional array and pointers, I told you there will be an internal pointer. So here we have an internal pointer and also an internal array of pointers. And actually the internal pointer points to that array of pointers. So earlier we studied, so I will go back to that slide. Here when we studied, I told you there will be a pointer called A, which also has the same address of the first location, that is address of first element. Similarly, listen carefully, here also I have a pointer that contains another array of pointers, and A of 0, this in this array of pointer, this A of 0 will contain address of 0th row, address of 0th row. Here this is the 0th row, A00, A01, A02. Then A of 1 will contain address of first row, A11, A10, A11, A12. Similarly, this A of 2 will contain address of second row or index position 2. So A of 2, A of 21, A of 22. And in the third cell, it contains the address of the last cell. So internally we have a pointer and also a array of pointer. Internally we have a pointer and also an array of pointer. So I hope you are clear with something. It will be more clear during the next slide. So here this is the actual array. This is the first row. This is the second row. This is the third row. This is the fourth row. Let it be an integer array. Let it be an integer 4-dimensional array. Let it be int A of 4. Listen carefully. If you can understand this diagram and the internal working, it will be very easy to study. A of 4. So A of 0, A of 01, A of 0. Sorry, this one is 02 actually. Okay, this is actually integer array of size A of 4. So if you're facing any difficulties, please say it immediately. If you have any doubt also, you can ask it now. So here A of 00, A of 01, A of 02, A of... Sorry, 1 minute. Okay, this overall thing will give a clear picture about the 3-dimensional array and its internal implementation. Here I have an integer 2-dimensional array, int A of 4. That means it will contain 4 rows and 4 columns. Anyway, I will take it row by row. First row means A of 00, A of 01, A of 02, A of 03. Similarly, second row means A of 10, A of 11, 12, 13. Similarly, I have the second row and third row. This is actually the 0th row. And I told you these cells are stored in memory in continuous memory location. Since it is an integer array, if the first cell have the address 1000, second cell will have the address value 1004, third cell will have 1008, 1012. Then you look at the second row. It also will be in continuous location. After first row, the memory for second row will be allocated. It will be in 1006, 1020, 1024, 1028. Remaining I have 2 rows. Similarly, remaining I have 2 rows. This everything will be in continuous memory locations. Okay. So I have, so here this is A of 4. So that is my actual array. When I declare A of 4, internally there will be another array. What is the size of that array? Size of the array will be same as number of rows. So it is actually an one-dimensional array. It is actually an one-dimensional array. So this is the internal array. So it contains 4 cells, A of 0, A of 1, A of 2, A of 3. The content of A of 0 will be the address of first cell of first row. A of 0 actually denoting first row, and the address of first cell will be stored as the value of first cell here. Similarly, in A of 1 we have 1016, and similarly in 1032 will be stored in second cell, and 1048 will be stored in third cell. So internally there will be a one-dimensional array also. It is totally invisible to the user or the programmer. It will be happening internally, and that internal array of pointer means an array which can hold the address value, which can hold the address values. And internally the row address will be stored here. So if any doubt on what we have discussed so far, you can ask. If anybody have any doubt up to this point, anybody have any doubt? If it is clear, please respond with a clear message. Okay. Again, listen carefully. I already told you, if there is an one-dimensional array, internally we have a pointer also. This is actually an internal one-dimensional array. For that internal one-dimensional array also, I have a pointer. I have a pointer called A. That pointer actually contains the starting address of 2D array. This will contain starting address because 1000 is the starting address. So earlier what we have studied in normal arrays is it will contain address of this cell. Here there is a slight difference. It's all happening internally. It is designed in a way that this pointer A will contain address of first cell. Address of first cell means address of first cell of the two-dimensional array. That is 1000. That will be actually stored in an internal one-dimensional array. First cell of the internal one-dimensional array. That same value will be stored in the pointer A also. These all are conceptual things and also internal things. Okay. So what will be, so just look at A, what will be the value of star A? A is also a pointer. You have to understand, A is also a pointer. My question is, what will be the value of star A? Varsha, Shibu?
Yes, sir.
What will be the value of star A?
1000.
Star A is 1000. Okay, you can mute the mic. So earlier we studied this A will, if it is an one-dimensional array, this A will contain address of this cell. But in two-dimensional array, in internal architecture, the address of first cell itself is stored in A. Star A means value at 1000. So here there is no need to take the value from here. It is actually pointing to this one-dimensional array. This A is pointing to one-dimensional array. So value at 1000 is also 1000. It is this 1000. So star A refers to A of 0. So my question, star A plus 1. Advait.
Yes, sir.
What will be the value of star A plus 1?
1060.
1016. Very good. In the morning session we studied star a plus 1 means 1016. Okay. So 1016 is actually a pointer, or a plus 1 means a of 1. That is also these things we have studied in the morning. Star a plus 1 means a of 1. A of 1 is 1016. It is actually pointing to another array. It is actually pointing to another array. I am writing one more thing. Star a plus 1 plus 1. Acknowledge Jose. Acknowledge Jose.
Yes, sir. Yes, sir.
What is star a plus 1?
1016, sir.
What is 1016 plus 1?
1020.
1020. Very good. It is actually pointing to this 1020. So that is actually address of A11. Address of A11. So this one is equivalent to ampersand of A of 11. Okay. So today that 1 minute. Actually I can't write it neatly. Star a plus 2 plus 3. Saksham Sedu.
Yes, sir.
Okay. What is A? What is the value of A? Saksham, I can't hear you. I think you have some net issue. You can mute the mic. Shashikant Singh.
Yes, sir.
What is A? What is the value of A? 100 or 1000? 1000. Okay. What is A plus 2?
A plus 2, 1000 to 4.
1000? 1000?
To 4.
Sorry, I can't get you. 1000?
1000 to 4, sir. 1024.
10?
24.
Okay. So actually what he tell, it is not clear for me. So I will tell you what is A.
No, sir.
A.
It will be because A plus 2, then A of 2, then I think 1032.
Okay. A plus 2 means actually this location. Actually it refers to this location. A plus 2. A is 1000. A plus 2 means it refers to this location. A plus 1 refers this location. It is actually A plus 2. So what is star A plus 2? Star A plus 2 means value at that location. What is the value at that location? 1032. 1032. Okay. Plus 3. 1032 plus 3 is 1032 plus 0 is 1032. Plus 1 is 1036. Plus 2 is 1040. Plus 3 is 1044. 1044. So this is same as ampersand A of 22. 2, 2. Okay. So ampersand a of ij. Okay, not 2, 2, it is 2, 3. 2, 3. So ampersand of ij or ampersand of 2, 3 equal to star a plus I star a plus 2 plus 3. Here it is j. So I hope you understood this point. Any doubt in this one? Any doubt in this statement? So ampersand a of ij is same as star a plus I plus j plus j. Okay. I'm clearing everything. So I'm writing on point. Star of star a plus 2 plus 3. Okay. Rohit PB,
Yes, sir.
what is A here?
1000,
A is 1000. What is A plus 2?
1032.
1032. Okay. Not 1032. A plus 2, we can't say it is 1032. A plus 2 actually refers this address location. It actually refers this address location. That way you have to think. Because A is 1000. Never look at this 1000. Look at this 1000. A plus 2. 1000 plus 0 points to this cell. 1000 plus 1 points to this cell. 1000 plus 2 points to this cell. So what is star A plus 2, Rohit?
1032.
Okay, that is 1032. This star A plus 2 is 1032. What is 1032 plus 3? John Ralphie. John Ralphie. Gautam S. Krishna. Gautam S. Krishna. Anu Fasmin.
Hello, sir.
Okay, Gautam. What is 1032 plus 3?
1044.
1032 plus 3 is 1044. Okay. So this entire expression we got as 1044. Okay. Then I have a star here. What is star 1044? Anu Fasmin.
Value at 1044.
Value at 1044. Value at 1044 can be written as A of 2, 3. A of 2, 3. So this entire expression is equal to A of 2, 3. So A of ij, A of 2, 3 equal to star, this star. Then I have a bracket, star A plus I, star A plus 2. Here in place of I have 2. Then a bracket plus 3. In place of 3 I have j. Okay. So I hope you understood the concept. Even if you have any doubts in this concept, don't worry about that. Understand these two lines. Understand these 2 points. Ampersand A of ij is same as star A plus I plus j, and A of j is same as star of star A plus I plus j. So even if you didn't understand this concept, understand these 2 lines. So this is only to show how I derived these 2 things, how I proved these 2 are same. How I proved these 2 are same. So these brackets are very important, because here first A plus I will be performed, then value at A plus I will be taken, then along with that value I am adding j, again I am getting some address value, I am reading the value at that address value, it will give value at A of ij. Is it clear? Can we move to the example problem? If it is clear, please type clear in the chat box. Okay. So I am not going to write any new example programs. I will just modify one of the earlier programs. So we already studied on program to read and print two-dimensional array. Read and print matrix. In pointer notation. Save. Okay. So ampersand a of ij's will be replaced with this one. So here I have an ampersand ij. So I am replacing it with star a plus I plus j. Then a of ij are replacing with star bracket, inside bracket again a star, again a bracket, a plus I plus j. Okay. So this is only to illustrate that these two things are equal. These two things are equal. So the application of this will come later, that we will study in next class. At that time it will be clear. The application will come later. So got some error.
Sir, bracket after main.
Bracket is there after main. Here it is.
Small bracket after main.
Where?
Line number 1.
Okay. Enter number of rows. 3. 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I get the exact output as we got earlier. Okay. This is the internal working, but the outcome is only these two lines. So you have to understand these two lines. So more problems we discuss when we study that. One more advanced topic we had to study, dynamic memory allocation. There we will discuss. So we are not going to study any new programs. We are only making slight modifications in programs which we have studied already.